Alright guys, welcome back to the class and I hope you guys are doing pretty good. Firstly, I want to know whether you guys are really enjoying how exactly we have designed this entire Java module. So do let me know in the discussion section of the video whether you are really understanding the concepts properly. The second thing over here guys is in today's class, we will be going through all the interview questions which are related to the topic of classes and objects as well as encapsulation. See, the thing is, your Java is such a vast module, and if you feel that once you have studied the entire Java for automation or your object-oriented program, if you have studied that, then only you will start with the interview preparation, then you tend to forget whatever you have studied so far. So that's the reason what I've decided is in between all these lectures, there will be special lectures which I'll be keeping only so that you can quickly revise for your interviews. Okay. So this is going to be one such lecture where we will only discuss the interview questions which are going to be related to the topic of classes and objects as well as encapsulation. Now, make sure when you are watching this particular video, you are fresh, first of all. The second thing is have a notebook or pen along with you so that you can quickly make a notes. Also, whatever the questions which I will be covering in this particular lecture, I have kept it in the download section of this particular video. You know how it works now. All right. So those things I have kept it so you can download it, take a printout of it and maybe study along with me. Okay. That's it. Now, without wasting time now, let's get started with the OOPS revision. Now, over here, guys, in this particular lecture, we will be discussing only 9 interview questions. How many? 9. Those 9 interview questions are first, a very basic question. What is a class in Java and how it is different from an object? The second one is, what are the various components of a class in Java? Then, what is the difference between instance variable and local variable? Then what is a constructor and what are the different types of constructors? This is going to be very important. Next, can constructor be private? What are the implications? This is also a very important one. So please make sure you are aware of question number 4 and 5. What is encapsulation and why it is important? Yeah, that is we are going to discuss, but I don't know whether people will still ask you this particular question, but still we have to discuss it also. What is this keyword in Java and why you are going to use it and when you are going to use it? So that's something which is important. And what is a immutable class in Java and how do you create one? So yep, this is an important one. So in this particular revision, the question number 4, okay, question number 5 and question number 7 and 8. These are the only one which are important. Rest one are pretty basic questions, but still it's for revision also, as well as if you're a fresher or if you have 2 or 3 years of experience, this question is going to be very commonly asked. Okay, so without wasting time now, let's get started with discussing all these questions. Let's go to the first question over here, guys, which is what is a class in Java and how it is different from an object. Now, the first thing, guys, try to cover the answer, okay, and try to answer it by yourself. What do you think? What is a class? Okay, whatever the answer you want to give, just make sure you are confident about it, okay, and you have a solid example ready, okay, to support that definition. Is this part clear? So don't just mug up. Of course, you might or you would do that, but the thing is, please make sure that you always have an example ready for these kinds of questions. Now, when I say a class is what? A class is going to be a rules which are going to be imposed on an object. Now, this is the definition which I have created and given it to you guys. But still, if the interviewer wants ki baba, no, you have to give me the theoretical answer. So, the theoretical answer goes like a class is basically what? A blueprint or a template which is used to create an object. So, how an object is going to behave is going to be decided by a class. Is this part clear to everyone? So right now, if I am teaching you guys, there is a rule which is imposed on me that I have to teach you guys, right? And similarly, there is a rule which is imposed on you that you have to act as a student and you have to listen what I'm going to say. Okay. So over here, whatever the actions which we can perform respectively is decided by those rules. Is this part clear to everyone? Perfect. So it defines, a class is going to define the properties. Okay, the properties are basically called as fields Okay, and the behavior is going to be the methods common to all the object of its type. Okay, common to all the objects of its type. This is very important. So over here, just to repeat one more time, a class is going to be a blueprint or a template, okay, to create an object. It is going to consist of, what a class is going to consist of? It consists of properties. The properties are basically what? Fields, as well as behavior. Behaviors are what? Methods common to all the objects of its type. Meaning, if there is another class, let's say car, the rules of car is not imposed on us because we are not a car type of entity, right? We are human type of entity or person type of entity coming into picture. So over here, classes are basically the rules that defines how an object will behave. I hope this particular part is clear to everyone. Perfect. If you guys are writing along with me, just take a moment and write it down by yourself so that like you are crystal clear with this concept. Okay. All right. So I hope you have written it off. Now let's talk about objects. Now, what is an object? Object is going to be an instance of a class with specific values for its properties and access to its behavior. Meaning, an object is going to have the instance variable as well as it can perform the actions, okay, the methods which is there inside the class. All real world entities are objects. Okay, this is very important. Now let's talk about memory allocations. Class. Class is going to be loaded in the method area during the runtime. So when you create an object, okay, a class will be loaded into the method area, whereas objects are created inside which memory space? Objects are created in the heap memory. Now guys, let's quickly write a template of a class. Let's say I want to create a class called as person. So I will say public class person. This is the start of the class. This is going to be the end of the class. I'm going to create a very small class over here. Next, over here guys, this particular class person is going to have instance variable. So let's say the instance variable that I'm going to create is going to be name. Instance variables are always going to be marked with private visibility label. Why? This is your data hiding. Okay, because we want to achieve encapsulation. Make sense? Now, instance variables are initialized where? With the help of a constructor. So you are going to create a constructor. Let's introduce a constructor. Constructor is what? Constructor is a method which has same name as that of the class. So over here, this is going to be a constructor. This constructor is going to have a parameter name. What is the job of the constructor? The job of the constructor is to initialize instance variable. If I am going to write name over here, my friends, what is name? Is name referring to my instance variable or it's going to refer to my local variable? Within a method, the importance is always given to the local variable. How do I call or refer to the instance variable? You will say with the help of this keyword. So when I say this dot name, Java refers to the string name or the instance variable name, and I can just say name. Okay. So when I say name, Java refers to the local variable. When I say this dot name, Java is going to refer to the instance variable name. I hope this particular part is clear to everyone. So over here, I have created a class which is going to have an instance variable and it has a constructor right now. You can have getters and setters and you can have various functionalities. So over here, I can just have one functionality. Let's say public void display information. And I can just display the information. So I'm going to say sysout name. Okay. So I'm just doing a sys out for name. So this is the behavior. Okay. Understand. This over here is the behavior, or what you can call as functionality. Okay. And this over here is my properties. Okay. Now, how do I create an object? Object can be created with the help of, okay, person class reference. I can say person P1. This over here is my reference variable equal to new person, and I can just give the name as, let's say, Raj. So my dear friends, this over here is my object. You can see new keyword popping up into picture. So this signifies that the object is going to be created in the heap memory. So when this object will be created, the constructor will be called. So the moment an object is created, what happens? Class is loaded into the memory, instance variable is created. Instance variable is going to be created where? Inside the heap memory, and it will be initialized with what? You will say default value, right? What is the default value of string? Null. And what is the next thing that is going to happen? Constructor is going to be called. So over here, name is going to get the value Raj. Okay, name is going to get the value Raj. Raj is going to come over here. This dot name equal to Raj. So over here, where null was written for my instance variable, Raj will pop up over here. We have seen it a lot of time. Okay, so this is the template, okay, of a class and an object. So what I can do over here is I can just say p1 dot display information. That is the only functionality that I can do with this object, because the object can only perform, okay, the functionalities which are there within the class. I cannot do anything else. Make sense to everyone? This object is going to follow the rules which have been defined in this person class. Is this part making sense to everyone? Perfect. Please make a note of this particular point. Try to write the code by yourself. Okay. Even on a paper or on a notebook, if you write it off, you will have a lot of, clarity how exactly the class, instance variable, methods, all these things gets called and executed. Make sense to everyone? Perfect. Quickly write it down. All right. I hope you have written this piece of code. Now let's go ahead to the next question. Okay, what are the various components of a class? Okay, now the reason I have introduced this particular question is so that you can see a full-fledged class. What all things or entities or components that can be there inside a class. Okay, now if I'm talking about a class now, the first thing is, of course, I can have instance variables. This is something that I can have. Variables that are going to hold the state of an object. Please remember this particular stuff. Variables which are going to store the state of an object. Okay. They are going to be my fields and attributes, my instance variable. The second thing that you can have over here is the behavior. That is, you can have methods coming into picture. The next thing, of course, you can have a constructor. So these three things we have already created. Yes or no? We have already created these three things. But apart from that, okay, there are going to be other things that you can definitely add in a class. Okay, you can have nested classes. Please make a note of this particular part. That is, inside a class, I can have another class. So let's say this is class A. I can have class B also inside it. Okay. Classes which are defined within another classes are called as nested classes. We have not built it because it's not required right now. When the right time is going to come into picture, I will introduce the nested classes for you guys. All right. Now, the second thing is the type of variables. You can have instance and static variables, okay, inside the class. Meaning, instance variables are basically variables which are specific to an object. So every time you are going to create an object, instance variables will be created. So over here, name and name will be created. Okay. But Static variables are variable which are going to be common across all the objects. So if I want to share something, if I want to share some data across all my objects, then I can use static variable. Again, there will be a detailed class on static keyword, so don't worry about it. This particular question I have only introduced so that you can see it, what are the various things that can be present inside a class. Clear? So I can have static variables, okay? I can have instance variable inside the class. These are the two types of variables I can have. Next, I can have nested classes. That is, I can have a class inside another class. I can have a constructor, which we already know. We can have methods. That is, we can have behaviors, functionalities inside a class. And we can have fields and attributes. That is, we can have instance variables. As simple as that. Now, over here, look carefully. I have created this sample code for you guys, and you can observe it by yourself. What are the different things which are there inside this particular class? Observe carefully. So here guys, I have a class called car, and inside the car, what do you see? I have two variables called brand and speed. What type of variables are these? These are instance variables which are created inside the class and is going to be non-static. Do you see a static keyword over here? The answer is no. So this is a instance variable. Then I have something which is called as a static variable. Now this over here, private static int total cars. This is not an instance variable. This is a pure class variable. Please make a note of this particular point, that static variables are pure class variables. Static variables are going to be shared across all the objects. Is this part clear to everyone? Perfect. Great. Then we saw the different types of variables. We have instance as well as your static variables coming into picture. Then we have a constructor inside this class. What is the job of a constructor? The job of the constructor is to initialize the instance variable. Look carefully. It is only taking parameters as brand and speed. Okay. It is not taking total cars as a argument, as a parameter. So what do you mean over here? So over here, that the constructor's main job is to only initialize instance variable. But over here it is updating. It can update a static variable. Is this part clear? Next, over here I have a functionality called accelerate. Okay, I have a functionality, a behavior that I can accelerate the car. So over here the speed will be increased. Then I have the getters and setters. Over here I have get total cars, get brand, set brand, right? So here I have the getters and setters. What do you do with the help of getters and setters? They are basically used for encapsulation. Binding of variables and methods together is called as encapsulation. Please make a note of this particular point. Encapsulation. Binding of variables and methods together is encapsulation. Now over here, this comes the interesting thing, guys. This is the interesting part. This is over here my outer class. Inside this class, I have created another class which is called as your engine. Now there is a very interesting thing that you will notice, that I have marked this particular class as static. Okay, let me use a different color. If you notice carefully, guys, I have marked this particular class as static. So sometimes in interview, they can ask whether a class can be static. Can a class be static? The answer is yes. Classes can be static in nature. But which classes will be static in nature? Inner classes. Inner classes are going to be static in nature. Is this part clear to everyone? Perfect. So this particular class is going to have its own functionality. Is this part clear to everyone? Perfect. So these are the things that can be there inside a class. You can have instance variable, you can have class variable or static variable, you can have constructors, you can have functionalities, you can have getters and setters, you can have another class inside a class. I hope this particular part is clear to everyone. Perfect. Can I move ahead? Great. Cool. All right, guys, now let's move on to the next question. And the next question over here is explain the difference between instance variable and local variable. It's a very easy question, guys. Okay, at least for us, it's easy. We already know what is the difference between instance and local variable. Instance variables are variables which are created for every object. Okay, whenever you are going to create an object, let's say I'm going to have this person class. Person P1, this is my reference variable. I am creating an object. Okay. So whenever I'm creating an object, class is going to be loaded into the memory. Instance variables are created and the constructor is called, right? So over here, guys, if you see carefully, in this example class, we have this instance variable called name. Variables which are created inside the class and is going to be non-static is called instance variables. Instance variable is going to be created in your heap memory. Any variable which is created in the heap memory is always initialized with default value. Yes or no? Perfect. It's always going to be initialized with the default value. So name, okay, is going to have the default value as null. It is going to be updated or it's going to be really initialized with the right value when you have a parameterized constructor. Okay. So over here, I have a parameterized constructor whose job is to assign the value whatever we are passing. So if I'm going to pass over here Raj, Raj will be given to this instance variable. Now, the thing is, whenever I have to refer to an instance variable, we can use this keyword. Okay. So over here, my dear friends, look at the constructor. Okay. Yeah. Constructor. The thing over here is, over here I have name. So this is going to be my local variable for the constructor. This dot name refers to the instance variable. Whenever inside a method, when the local variable and the instance variable, they have same name, then we have to use this keyword to differentiate between them. This keyword is always going to refer to the instance variable. Now, talking about local variables are declared in a method. So over here, if you look at the greet method which we have, here I am creating a local variable called string message because the declaration is there now. Whenever you give a data type followed by the variable name, this is declaration. So this over here is a local variable. Local variable is going to be created inside which memory space? Stack memory. Local variables are never implicitly initialized with default value. Please make a note of this particular point. Whenever you are going to have any local variable, you have to do explicit initialization. This is important. Clear? Now, over here, guys, even if you look at this calculate square, int square is a local variable. Number over here is a local variable. Whether you have a parameter, number is a parameter, int number, I'm passing a parameter. No? And int square, this is also a declaration. Parameters and variables which you create inside the method, they all are local variables. Clear? They will be created in the stack memory. Clear to everyone? Perfect. Please read these 6 points. I'll read it for you guys quickly. Instance variables are going to be created, okay, for every object. Whenever you are going to create an object, instance of variable will be created. They are going to be stored inside the heap memory, and they can be accessed with the help of this keyword. Okay. Now, what is local variables? Variables which are created or declared within a method, they are called as local variables. Also remember, parameters of a method are local variable. They are stored in the stack memory. Local variables are stored in the stack memory, and in a method, local variable is always going to have the highest level of importance. That's the reason if you look at the constructor also, now I'm directly calling name. So if I'm writing name over here, Java is always going to refer to the local variable and not to the instance variable. That's the reason we use this dot name over there. Make sense? Quickly make a note of this particular point. All right. Let's move on to the next question now. What are constructors in Java and what are the different types of constructors? This is going to be very important. What is a constructor? A constructor is a special method that has the same name as that of the class. Pretty simple. First point is pretty simple. You have seen it a lot of time now. The job of the constructor is to initialize the instance variable during the object creation. I hope this part is also clear to everyone. Now, constructors do not have any return type. This point is not written over here. Please make a note of this particular stuff. Constructors don't return any value. Okay, so constructors don't have return type. Setters, okay, have return types. Methods are going to have return types. Constructors don't have return types. Okay, the different types of constructors that are there in Java is basically a default constructor. The first one is a default constructor. What is a default constructor? Let's say, guys, this is my person class. Okay, let me write class also. So over here, a default constructor is a constructor which does not have any parameters, no arguments. This over here is a default constructor. Clear to everyone? This is a default constructor. What is a parameterized constructor? Parameterized constructors are basically constructors which are going to have parameters. As simple as that. Over here, if you look carefully, this is a parameterized constructor. Example, string name. So we are passing a parameter to this constructor. So this becomes a parameterized constructor. Now, next constructor, which is very important, which is called as copy constructor. Okay, which is copy constructor. A copy constructor is basically what? It is going to create an object by copying data from another object. Please make a note of this particular point. Copy constructors are basically constructors which is going to create an object by copying data from another object. Okay. Then you can also do constructor chaining. One constructor calling another constructor is called constructor chaining. Please make a note of this particular point. One constructor which calls another constructor of the same class is called as your constructor chaining. Okay. Now, then you can do constructor overloading. Multiple constructors with different parameters. Multiple constructors with different parameters is constructor overloading. Is this part clear to everyone? So these are the different types of constructors which are there. You have a default constructor. Default constructor is a constructor which does not have any parameter. Parameterized constructor, constructors which have parameters are parameterized constructor. Copy constructor, copy constructors are basically used to create an object by copying data from another object. Then constructor chaining. Constructor chaining basically means what? When one constructor calls another constructor is called constructor chaining. Then is constructor overloading. You do method overloading, na? So over here, when you have constructors with different parameters, you call it constructor overloading. Let's look at the example also for this one. So over here, guys, look carefully. This is my person class. This person class has two instance variable, name and age. So over here, the first one which you see is a default constructor. Why? Because no parameter. Parameter is only not there. So this is a default constructor. The second one that comes into picture is parameterized constructor. A constructor which has parameters is parameterized constructor. Now, if you observe carefully, here only constructor overloading has happened. Why? I have two constructors, okay, but the parameters are different. Over here, I have 0 parameters, and over here, I have 2 parameters coming into picture. So, this is, okay, parameterized constructor also, and over here, constructor overloading is also happening. Now, if I look at the third constructor is a copy constructor. Over here, I'll be passing the object reference of some other person class. Okay. And we will take the data from that person class object. Okay. And assign it to this particular object instance variable. Okay. So, what it basically means is, see, over here, let's say, why this crayon gets selected all the time. Over here, guys, let's say this is an object of person class. This is name. Let's say name is Raj. Okay, that's okay. Next one, let's say there is another object. Let's say we are trying to create an object over here, and the reference over here is, let's say, 777. So we will pass the reference of that particular person object. So what Java is going to do is going to take this particular reference other which points to 777. Okay, it's going to get the value of name. What is there of the value of name? Raj. So Raj will be coming over here. This value of Raj, we are taking it from other object and we are giving it to this current object. So over here, name is going to get the value Raj. So when you take the data from one object and you use it to create object of some other class, initialize the instance variable of other class, you do that with the help of copy constructor. Is this part clear to everyone? Great. Then if you observe carefully, we are also doing constructor chaining. This is my another constructor. If you look carefully, guys, what is happening is if I want to call another constructor of the same class, we will be using this keyword. This keyword is used to differentiate local variable with instance variable. This keyword is used to refer to the current object. This keyword is also used for constructor chaining. When I say this round bracket name comma 0, what is going to happen? The control is going to go to this particular constructor. Okay, so this constructor will be called. When one constructor is calling another constructor, it's called constructor chaining. Is this part clear to everyone? Perfect. So over here, this is how I am calling the default constructor. This is how I am calling the parameterized constructor. If I go down, this is how you are creating an object with the help of copy constructor. I am passing a reference, na P2 reference. Okay. Then here I am trying to do constructor chaining. I am only passing one parameter, Bob. Okay. And this particular constructor internally is going to call this another constructor. This, okay, round bracket name comma 0. All right. So it's going to go from here to here. I hope this particular part is clear to everyone. This is a very important. Please try to write the code at least once for this particular class. Okay, write the code by yourself. All right. All right, guys, this was a very important interview question, which is what are constructors in Java? What are the different types of constructors? Just to revisit it one more time, the different types of constructors are default constructor, parameterized constructors, copy constructors, constructor chaining, and constructor overloading. Can I move on to the next question now? Perfect. Great. Now, the next question that comes over here, guys, is can constructors be private? And the answer is yes, constructors can be private. But in which use cases you are going to make the constructor private? Constructors can be made private for singleton class. or singleton design pattern whenever you want to implement a singleton design pattern. As of now, just remember that if you want to restrict multiple object creation, if you want only one object, then you will be implementing singleton class. Okay, singleton class. We do it for database connectivity, okay, logger creation and all. We generally go for singleton class over there. Then utility class. Sometimes if you're going to have utility classes are going to be classes which we have reusable methods. Generally in utility class, you are going to have most of the methods as static. Okay, so that they become accessible anywhere in your project. So in those utility classes, you can make the constructor as private so that no one actually instantiate or create an object of those classes. Then you have factory pattern coming into picture. If you want to control object creation only via factory methods, then for those respective classes, I will make the constructor as private. Just remember this particular point. We will discuss about it in future. Right now, it is not the most important thing for me, but I believe you will be able to remember these 2 points. Okay. So just remember, for singleton pattern, you can make the constructor as private. For factory pattern, you might want to make the constructor as private so that the object creation only happens via factory methods. And for utility classes, in order to prevent your object creation for those utility classes, you can make the constructor as private. All right. Let's move on to the next question, which is pretty simple. What is encapsulation and why it is important in Java? Tell me the definition of what is an encapsulation. Binding of variables and methods together is called as encapsulation. What type of variables are we talking about? We are talking about instance variable. Read over here, guys, quickly. Wrapping of data fields and methods in a single unit. Okay, wrapping of methods as well as the variables, the instance variable together of a class, and restricting its access via methods only is called as encapsulation. And we do it so that we can hide the data, okay, as well as we can have controlled access via getters and setters only. Because if we are going to have getters and setters, we can introduce validation logic. We can have validation logic coming into picture. As well as with the help of encapsulation, you can control what kind of values that can be used to initialize those instance variable. Remember, right, in your class, instance variable are going to be the most important variables. So you want to make sure only correct values or valid values are used to initialize them, right? So it is going to help you improve the maintainability as well as the security of your data. Is this part clear to everyone? Okay. This can be asked in interview. They can also ask in interview where you have used encapsulation. Okay. So in all your classes, in all your Pojo classes, you generally create encapsulation. Please make a note of this particular stuff. In all your Pojo classes, you do encapsulation. Now, guys, let's move on to the next question, which is pretty simple. I'll just read it for you guys. What is this keyword in Java? When and why it is used? Now, throughout this entire class, we were discussing about this keyword. So I'm pretty sure you're aware about all the points over here. But just to read about it and just make sure that we remember all these points, this keyword is used for multiple things. Okay. The first thing is it is used to refer to the current instance, and we have used it in the equals method. So whenever I have to refer to the current object, I will be using this keyword. The second thing is if I have to differentiate local variable with instance variable within a method or a constructor, then you're going to use this keyword. All right. The next thing that comes into picture is we use this keyword for constructor chaining. So in order to call another constructor of a same class, okay, we use constructor chaining. And note that, and remember, this is very important, that a constructor only can call another constructor. Okay. Only a constructor can call another constructor. Please make a note of this particular point. If I go up to the constructor chaining, you see this person is my constructor, and only this constructor is calling my another parameterized constructor. Makes sense to everyone. Only a constructor can call another constructor. Okay. And in order to do constructor chaining within the class, we use the this keyword. Clear to everyone? Perfect. Now, the next thing that comes into picture is returning the current object in the method chaining. Okay. If I want to return the current object when I'm doing a method chaining, I can use this keyword. So these are the four places where you will be using the this keyword in your Java. This can be asked a lot of time in interview. What is the purpose of this keyword? So first one, it is used for what? Referring to the current object. Second one, it is used for differentiating local variable and instance variable in your setters as well as in your constructors. Second thing is it is going to be used for constructor chaining. Okay, that is when a constructor calls another constructor, it is called as constructor chaining. And in order to do constructor chaining within the class, we use this keyword. And also, if I want to return the current object in a method chaining, okay, if I want to return the current object, okay, during the method chaining, I can use this keyword. All right, please make a note of all these points. Finally, we'll move on to the last question for today, which is explain immutable class in Java. How do you create one? First of all, you need to understand what is a immutable class. Immutable classes are classes whose instance variable cannot be updated. So, an immutable class is a class whose objects cannot be modified after creation. So, those instance variable of this particular object cannot be modified. Any change to the object results in the creation of new object. You have seen this kind of a expression or this kind of a line in one of a Java topic. Whenever you modify a string, a new string gets created, right? String literals. So over here, the most common example of a immutable class in Java is string class. Now, how do you create a class as immutable? First of all, you have to make sure that you are making the class as final. So prevent the class from being extended or inherited, ensuring no methods can be overridden to compromise immutability. So whenever you talk about immutable class, you have to make sure that the immutable class are final in nature. Okay. So class has to be final in nature. The second thing is variables are going to be private and final fields. All the instance variables of your class are going to be final and they are going to be private to restrict direct access. Okay, to restrict direct access. If you create a variable as final, final variables cannot be modified. The use of final keyword ensures that the field cannot be reassigned. That is, you cannot modify them after initialization. Also, if you talk about immutable class are not going to have any setters. They are not going to have any setters. So setters are not going to be present in your immutable class. So do not provide methods that modify the object states or object's instance variable. All the initialization is going to happen with the help of constructors. So set all the fields via constructors only. All right. So these are the steps for creating a immutable class in Java. Now let's try to understand how we can create one. So over here guys, let's try to write a simple class code so that we can understand how exactly a final class is going to look. So over here, let's say we want to create a final class. So a final class is going to be what? Public final, let's say A. A is my class which I want to make it immutable. So whenever I say I'm going to have an immutable class, it is going to be final in nature. The next thing is inside this particular class, if there is going to be an instance variable, this instance variable is also going to be final. Okay. And it is going to be private. Clear? So X, my instance variable, is final in nature so that it cannot be modified. Okay. And inside this particular class, guys, I am not going to have any setter. What are we going to have? We are going to have a constructor. So I'm going to create a constructor of this particular class. It's going to have this parameter called X, and we are going to say this dot X, meaning we are referring to this instance variable is going to be initialized with whatever value. Okay. Done. Okay. So this, my dear friends, is the sample immutable class in your Java. Is this part clear to everyone? Please practice this code over here. Pretty simple. So if you see the class is final, then you see private and final fields. The instance variable that I have is private and final. There is no setter. I don't have any setter. Can I have any other methods? Yes, you can have other methods, but setters are not going to be there. You cannot modify these values. Okay. The second thing is for the instance variable, any kind of initialization is only going to happen with the help of constructor. So there is a constructor. This constructor is going to be public. Done. All right. So that's it, guys. These are the important interview questions for your topic of classes, objects, your encapsulation, this keyword, constructors, and all. If you have studied this much part also, right, I'm pretty sure you will be able to answer all the questions related to these topics. Also, guys, I hope this particular session was useful for you guys. So do let me know in the discussion section of this particular video if you want to have more lectures like these. And also, don't forget to mark the attendance of this particular video. Now, I'll be seeing you guys in the next one. Till then, take care. Bye-bye.